Alrighty. Okay. So, I guess we can start now. So, today, our lesson is going to be on input and output. Now, in the past lessons, we've talked about a lot of things varying from like loops to if statements and all that fancy stuff. But ultimately, what a program is all about is you want it to do something. And in order for the program to actually do something, the program needs to have its data. As we remember, the two most important parts of a program is data and instruction. And without either of them, you cannot perform the action that you want it to perform. And so we learned kind of the basics of instruction, and this includes everything from like our if statements, our for statements, our collections, our variables, all that stuff. But now we're going to move on to our actual data and how the program can access this data. And after it can access this data, here comes the second part, which is output. And output can be almost anything as long as it's something that the computer, I guess, can um, connect to in some way. But essentially, what happens is the output is the anything that will display it on like a GUI scale, which is essentially just like printing out your output, or anything like a speaker. So basically, any way that the computer can tell you that it did what it needed to do. So we're actually not going to use this presentation first. We're going to go over here, and I'm going to see if I can change that. Um, all right. Okay.
Okay, my screen can be seen, right?
No, you need to press your screen one more time.
Oh,
All right, we can see it now.
okay. So to make programs useful, you have to be able to input information to it, as Matthew said. The most basic way to input in Python is the input keyword. When run, it takes something that a user types and assigns it to a variable, like here. So inputs in Python are recorded as strings. So if you want to record an integer, you have to put int before the input function. Something like here, you have to define it as an integer instead of a string. So this is the input function. It's pretty easy to understand. You just type what you want to put inside, and then it will make that your input. So obviously, you also need an output to actually see what your program does. So print is one way to do this. Since you already know what print does, we can learn some things that help make print more intuitive. So the first thing is the separate keyword. It's used to separate multiple items in a print function. So without it, you see in this one, right? It says print foo42 bar, and you want to put like something in between, right? So instead of adding one like one thing that you put every time, you can just put the separate function at the end, and it will do that for you. You can also squish objects together by making a separate empty or just a space. So here's the end keyword. It will cause the output to be removed by string instead of making a new line. This is useful for, solving this problem when you have different things in loops. Instead of them making new lines every single time you print something, you can instead use the end function to make them print in one single line. So these are more complex print print functions. We don't really need to know these right now. So we can skip to the next part. Okay. So one thing you can do to make print, another thing you can do to make print more intuitive is using modulo operators, which are like percent things on your keyboard. It's usually used with numbers to remove to find the remainder in division. Like here, 11 divided by 3, its remainder is 2, because you can't divide 2 by 3, right? So the strings, though, they have an entirely different function. Um, they with strings, wait, so with strings, format, they help format the print statement. Um, I'm not really sure myself, but
It's fine. This is kind
exactly,
of like the
I
more
think
technical stuff, so you can kind of look over it yourself later. So I guess let's continue on with this website. So as we saw, there's like the conversion table. So if we look over here, and we pull that up, I believe that is down here. So there's going to be like a lot of different conversion types, and all of this is kind of really technical stuff. It'll take you a little while to kind of understand it yourself, as this stuff is kind of the stuff that comes with like practice makes perfect.
yeah.
Although the next part of our lesson is going to be more focused on the ideology behind input output, why you would need it, and its different uses, examples in real life to kind of help you understand why input and output should be used in your programming and how you may use it unintentionally. So I'll kind of put the link in the chat so you guys can look at this um, website in more detail if you guys want. Now this website is like packed with information. Um, Honestly, it would probably take a good 2 weeks for any decent programmer to go through this entire website, because there's a lot of kind of information in here. So feel no need to rush yourself through this entire website. Just take your time and make sure you understand each one of the things that it talks about, because it talks about a wide range of different inputs and outputs that can um, be written into your Python program. So let's continue with the presentation then. So we learned that the computer programs are just like essentially machines, except these machines, um, they obviously compute a lot of binary. Now, most of these machines have some way for the user to kind of input their instruction, or input whatever you want that machine to do. Like this example over here, the air conditioning. So the input panel is where you can enter your desired temperature. Your input panel in your like say oven, it can be what temperature you put it at. So there's obviously going to be a lot of things in our lives that we can see how we input our instruction, and some sort of machine does something else for us. And what that thing does for us will produce something known as an output. Now for the AC unit, the output of the AC unit is essentially just going to be maintaining the temperature that you set it to. So say it's like really hot and you want to change the temperature to something cooler, and so you turn down the temperature, then what you're going to go ahead and do is you just set the temperature, and the AC will start running cold air through the house to try and maintain a colder temperature. And so this is kind of like the basic premise of how input-output works, and this is literally going to be the exact same of how it's going to kind of look in a program, except obviously in a program there's going to be kind of more ways for you to input and more ways for the computer to output than just inputting information into a panel and outputting the AC unit through the AC unit rather. And so we'll kind of give you a little time to think about like other examples of input and output in your lives, and kind of think about this. So we can move on. So now we kind of see we're going to move on to input and output specifically in programming. So in programming, your input is going to be anything that you obviously want the program to do, just like any other machine. Now, computer programs, they can be designed to do specific things. Now, these things can't be like actual physical things. Rather, like you can't like cool down the temperature like the AC unit. But essentially, what these programs can do is they can perform any type of calculation. They can like answer some sort of question for you. And so this question has to be written through a program. And so there are obviously many programs out there that are designed to kind of answer your desired questions or run in a certain way to complete something, complete a task for you. And so there's some programs that are kind of not necessarily, we don't really think about them as programs, and so these are called apps. Now apps, I know like it can range from anything from like a game to some sort of like I don't know, a web, like a online reservation app, right? Like this example over here. But behind all of them is going to be the same exact thing, which is programming. And so obviously the programming behind these can vary in difficulty or complexity, and typically like the higher quality the app will be, the more programming will go behind it to make sure that it runs smoother, all the input and output is done with ease, and that the users have the best experience they can on that app. And so if you were to do, say, like an online reservation, then you can input your days of traveling, destinations, and preferences. And what the computer program will do, or what the app will do, is essentially it will like go and it will document this for you, and it will run behind the scenes some sort of program. And so this program will then output you a list of travel options, and this kind of list of travel options will match the similarities that meets your needs. And this is kind of one of the basic kind of examples of how input and output is used in real life. So you'll kind of see this really commonly in like say advanced search. So if you were to just regularly search for something, say like a book name or some sort of article, and you were to input the main topic of that article, obviously you're going to get way too many results. But if you were to use advanced search and you give it more precise, more accurate data so that it can kind of narrow down your options for you, then it's much easier for you to find it. And so, as with any program, the more data you give the program, the more accurate it can perform your calculation or whatever you need it to. So kind of take a moment to think about this. Alright, let's move on. So, now that we've kind of talked about the basics of how input and output work in a program, in like regular programming, without any specifics, here are going to be kind of the two main like overlying ways you can input data into your program. Now, I'm sure you guys have used variables in your programming if you try to practice it, and essentially what these variables do is they store any data. Now, this data is going to be um, accessed only through the program itself. So that means that the only way to change this data would be to go to the program and change that line of code that says, say, num of students is equal to 23 to num of students is equal to 33. And essentially, what this means is that it's not very easy for a user to access this data. And the reason for this is because as a regular user, you don't have any access to kind of the background code behind this, or the code that runs behind the program. And essentially, if they aren't able to access any of the code behind any of the code, then that means that they can't change any of the data. So if you were to run the same program over and over again, you just get the same exact answer over and over again. Of course, with the one exclusive case being if you use an input of random numbers. And that's something that we can talk about later. But essentially, the data, it's in order for you to input it, there's going to be a more efficient way or a more user-friendly way in order for users to be able to easily use your program. And this is going to be user input from the console. Now, what in the world is a console? So many of you, like if you play any games, a console is going to be like an Xbox or a PS4. Now, what the console in this means is that when you run your program, there's going to be a window that pops up. So this has nothing to do with the console that you thought of before, but essentially it's going to be kind of like a run window, and this is going to show all of your text output, and this is going to be where you can type in your text input. And so it's going to be kind of like a blank page. So if you were to run like a hello world program, then you would kind of see a new Python window open up, and you would see hello world print. Now, if you were to have user input from the console, which is what you would type over here, then essentially what would happen is it would go like, oh, okay, so this person wants an input. So what I'm going to do is I'm going to let them type in, and whatever they enter in on this line, that's going to be their input. And that is going to be stored in whatever I wanted to store in, or whatever I want to do with that. And so in this case, in this example, you're first going to enter your name, and then you're going to enter in a number. So that brings us into another topic, which is known as casting. So casting essentially means that when you type in your inputs, there's no way for the computer to kind of tell, oh, this person's typing in a string, or oh, this person's typing in a number, because to the computer, all you're typing in is a bunch of characters. It can't tell, oh, this is a number, oh, this is a character, or oh, this is a letter, right? So essentially, what the program does is, in order for you to be able to kind of take in that input and store it as a number, because remember, in Python, you cannot define this variable as an integer, because, well, when you define it, all you need to do is just type in the variable name. And so that's where you kind of see this int over here. And what int means is essentially whatever number or whatever you type into there, it will convert it to an integer. Now, if you type in, say, F or J, then obviously you can't do that because it's not an integer, right? So if you're to type in 9, say in your name input over there, where it says enter your name, essentially what would happen is it would recognize 9 as a string. So essentially double quotation marks, 9 double quotation marks. Now, since it's a number and it's casted to an integer, then that means that the value stored is going to be the integer 9. So this means you can do all your regular math calculations and it's not just a printable string. So this can be a little hard to grasp, so I'll give you a little to think about this. Now that you guys have had a little to think about this, we can move on. So obviously, we have these two kind of inputs over here, and we kind of saw user input is from the console is much more user friendly. Now, if you're just kind of doing this as like a one-time program or something like that, you don't intend on using it over and over again, then obviously it's okay to hard code the values. But if you're intending on using your program and like doing something that is helpful to you or someone that you know, then user input from the console would obviously be much easier for you to run the program and for you to input the data that you want. So this is where we move on to files. Now, files, this can be any type of file. This can be some sort of text file, this can be an audio file, it can be a video file, and this is where programming starts getting interesting. And why I say this is because this is the basis of AI applications, or how a computer can actually learn. Now, it certainly is not very hard for a human to type in a bunch of characters to tell the data that you want to tell an AI machine. However, who carries around a keyboard all day? And sometimes it can be a little annoying to say put a keyboard next to something like an Alexa in order for you to type in any type of data that you need to give the Alexa in order for Alexa to give you an output. Oh, and that is our Alexa going off because I just said its name. Alright, but essentially, this is kind of example how AI can, this is kind of like the basics of AI, because the main ways that a human kind of can communicate and how a human can analyze a situation is through sight and sound. And so this opens up two entirely new kind of branches of programming: natural language processing, and computer vision. And you may be wondering, well, what's so hard for a computer to listen to you, or what's so hard for a computer to see? Well, you see, computers are kind of like newborn babies. They can hear everything that we say, they can see everything that we see, but they cannot comprehend it in any way that a human who's learned the basics of like society, I guess, the basics of what a teacher would teach them in class, that has taught them, because essentially it has no grasping of its surroundings. And so that's where natural language processing and computer vision come in, because all that it's essentially receiving as an audio file is going to be a bunch of gibberish, because there's no way for it to understand it as it doesn't have any previous knowledge. On top of that, a program will analyze kind of an audio file, not by like our regular, I guess, standards of just kind of listening to a person, but by its sound waves. And what's so difficult about these types of branches is that each human will kind of have a slightly different accent. And so um, any change in the voice, any change in pronunciation, even from the same person, like from word to word, um, the program has to know how to account that. And I know this is getting a little bit far, but essentially, this is how input and output get really, really important into programming. And so, natural language processing and computer vision both require these kind of image files. And so, these are image or video files or audio files. And so, these files are then input into the program, and the program will either read it in order to try and understand it, or it will read it to kind of access more information. Because remember, these programs all have no kind of background information, so they have to learn everything from scratch. So now that we've kind of learned, okay, so we can upload files, right? We can upload, we can enter in any data from the console. We can enter it in through hard coding. Well, there's one more thing that we can kind of enter in our input through. Or one more main thing, and that is going to be GUI. So I'll kind of let you look at this app over here for a second. So the reason why I say this is kind of like the last one is because this is the last kind of input that can kind of easily be accessed by a beginner programmer. Now, there are two more types of input that we will go on later in this presentation, but this is kind of going to be um, your glass ceiling, I guess, in a way, because essentially anything past this is going to be require a little more knowledge into either graphics or electronics. So this is going to be manipulating your GUI or your graphics user interface. And what this means is, as you can see, you have this kind of box over here with all these letters, all these boxes, all these buttons. And so this is essentially known as a GUI or a graphics user interface. So a graphic essentially means something that you can see. User means that a user can interact with it, and an interface is the actual interface or how you can actually interact with this. Um, so essentially, what's happening here is the user can enter in the name by typing it in. You can choose the folder, or essentially attaching a file, and next is going to be selecting any integer for the frames, and your final one is going to be how fast. And so this is kind of a combination of everything that we've learned before. And so this app, the reason why it's not associated with the next one that we're going to go over is because it is not something that is able to be accessed online unless you're like implementing it through something uh, that is not kind of like a private connection, I guess. I don't really know how to explain it. But essentially, when you run the program, this is what's going to pop up. And you're going to kind of enter in your inputs, and it will give you your output. And in this case, it will give you a GIF, or a GIF. I don't know how to pronounce it. But this is kind of the very basics of a GUI interface. And this is going to be like how many of your like small projects are going to be written. It's all going to be written onto this graphics user interface. And a graphics user interface is also somewhere where the computer can output stuff. I guess we can move on now. So next is going to be a web browser. Now, a web browser is going to be slightly harder to actually program because, well, this involves designing an entire kind of website. Now, obviously, when you look at this website, it looks nothing like this. And the reason for this is because, well, Spotify put a lot of time to make it look appealing to our eyes. But in reality, essentially what this is there's a button here to click on the home page. There's a button here to download Spotify. There's a button here to download Premium, one for help, another one for downloading, one for signing up, and one for logging in. But the difference is that it's been masked in a way to look appealing to our eyes. And so essentially what's happening is this kind of website uses something known as the Django framework. And this framework is the backbone of a lot of good websites, I guess. As when you click on any button or song list or anything on this website, like logging in or buying premium, that request is sent to Spotify's web server, or essentially this kind of web server that takes your any input that you put into the website, and this web server will essentially analyze it like, okay, this user wants to download Spotify, and so this Python code that is behind all the Spotify web server will then process this request and will respond. And this can be with a file ready for you to download. This can be any way that you want to download Premium or something like that, or say a song you wanted to pull up, and so it will process whatever request you put in. So this is kind of how a web browser or web app will work. And so this web app is not only for for websites, but is also for, say, any app. So any app means that it can be, say, even like the Spotify app. So essentially, any sort of thing that can connect to the internet and is sent back to a web server. So I'll let you look at this for a second. Alright, so we are now moving on to our final type of input. And this is going to be electronic devices. So electronic devices can be anything from sensors to transmitters, any kind of electronic device. And so this picture on the right shows a picture of Python programs running on a Raspberry Pi. So this is going to be this over here. And this green little board may look kind of familiar. And the reason for that is because, well, it's essentially just a miniature motherboard. And so this mini computer will take inputs from any sensors that you put in, and in this case, it will take it from a humidity and a potentiometer sensor, and it will display whatever information it has on the LCD panel right here. And what this means is that it's outputting information. So this is kind of an example of our output. And these electronic devices, there's obviously tons and tons of sensors. There's tons and tons of projects that you can do with it. It may be a little hard to get your hands on as a beginner, because obviously there's going to be a lot of models, suggested ones, reliable ones. But essentially, this is how you can help your program assess the real world. Assess, say, the actual temperature in your house, or the humidity, and so anything that there's a sensor for, your program can access. It can access sound. It can use video. Um, we even wrote a program to track a tennis ball, like a bright neon spot. So I'll let you look at this for a little bit. Alright, we can move on now. So that brings us to outputs. So outputs is going to be kind of very similar to your inputs, except the other way around. So it can say print a console. It can output to files. It can output to your GUI, and it can obviously output as a response to the web browser. Say bringing you to a new URL, I guess, and that will allow you to do whatever action you want. So these are kind of self-explanatory, so I'll let you look at this for a little bit. Move on. So output to an electronical device. So this has slightly more variety. Now this is not going to be outputting through sensors or something like that. You're going to be outputting through motors, LEDs, screens, um, speakers, and so essentially this Python program can control the motors of this robot, and it knows where it's going because, well, there's an ultrasound sensor on top, or a sensor that assesses the closest object to it. And that is kind of how this Raspberry Pi program can run. And so its output will be, oh, I'm far away from this object, I want to get closer. So its motors will run, and it will move itself closer to the object until, obviously, it crashes, or the sensor tells it to stop. So I believe that is all for our class today. So if you have any questions, please remember to ask them in the chat, and if you don't, thank you for watching. Alright, thank you everyone for watching, and we'll see you guys on Friday.